Hey peeps, I just wanted to put a little quick note in there. As I was doing my video, my daughter said, "Man, Dad, you look mad." Well, to be honest, I'm not really that happy, that's for sure. But no matter what, I miss you guys a lot, and it definitely would be a lot easier to teach doing this a different way, and I would much rather be at school. But I'm committed to doing my best, and I thank you guys for sticking with me. And I hope that you're committed to doing your best as well all the way to the end. So let's stay together. Let's keep doing our best. If you need any support, make sure you give me a call. 406 651 9072. Okay, bye. All right, so today we're going to do a fourth learning goal that's really directly off of the last learning goal. Okay, learning goal number 4, I can graph systems. Okay, that's a really big idea right there. Systems of linear inequalities. So we've been doing linear inequalities. Okay, so when it says systems of linear inequalities, that means we're going to graph more than one at a time. And then our answers have to be able to satisfy both equations. And even towards the end, we might even get to a point where we do 3 equations, and you'll see that. Okay, so go ahead and get a piece of paper. Get ready to take some notes here. All right, so this is our first example. And I kind of wanted to keep it a little bit simple, but yet you can still see some big ideas here. So if we say x is less than or equal to -2, okay? Obviously there is no y, so that means our line is never going to cross the y-axis, right? So I go here at -x, this is our x-axis, here's our y-axis, we go to -2, 1, 2, all right? It's less than or equal to, so I know I got to draw a solid line. Now, this is where it's going to be slightly different than what we did in the previous. At this point, we know that we want to shade everything less than, right? So I got to shade everything this side, but I'm not going to shade yet. All I'm going to do is put an arrow saying if I did shade, I would be shading this side. Okay, that's a really big idea. Next, we go to y, 3, 1, 2, 3. Okay, obviously it's not going to cross the x-axis, so, oh, and it's also a dotted line, isn't it? Because there is no equal to. Okay, dotted line. All right, and it says shade everything. It's greater than, right? So we shade everything above. Now I know all of a sudden they're starting to look like a lot of lines here. But you can see this region right down here has 1 arrow in it, doesn't it? Okay, this region, how many arrows does this region have? This region has no arrows, right? There's no arrows pointing into this region. Right up here, there's just 1 arrow, and you notice right over here, there's 2 arrows pointing into this region, right? And I know I've kind of got, but so if there's 2 arrows pointing into this region, then that is the area that we shade. So if this thing would have been dotted off more like this guy goes straight up like that, okay? Sorry that my graph kind of ran into my problem, but hopefully you guys have a little bit more space. But that's what you do is, okay, notice 1 arrow, no arrows, 1 arrow. Does everybody understand that? This was the place that had 2 arrows. There's an arrow here and an arrow here. That means that this is the region of your graph that satisfies both equations. So that's the region that gets shaded. So here's example number 2. All right. Again, we're talking about systems of linear equations. Obviously, this one's y has already been solved for. Y has already been solved for here. I'm going to give you a minute to get them copied down. It'd be interesting if you could do it on your own. If you can't, that's okay. We're going to do this example together. But take a minute, push pause, get your paper looking like this, and then we'll get started. All right, so let's start with this guy. Obviously, you guys know that there's an understood value of 1 right there, so I'll slide that in there. We're going to start by graphing -2. So here we go. Down 1, 2. It's our y-intercept, slope of -1. So that means we're going down 1 over 1, down 1 over 1. Or we could be going up 1, back 1, right? That's a negative slope. Okay, dotted line or solid line? That's right, we're going to go dotted line. Okay, dotted line, that says greater, right? So the snow's got to go on top of the roof. Now remember, this is where I just put an arrow. Say if I was going to graph it, I would go greater than. Okay, over here, up 6, 1, 2, 3, 4, 5, 6. Dot there. Slope is 3 over 1, right? Up 3. 1, 2, 3 over 1, or down 3. 1, 2, 3, back 1. Okay, dotted line are solid. Solid, right? Because there's an equal sign. Okay, solid line. Shade above or below. Well, it says less than. Y is less than or equal to, right? The alligator's eating this, so this must be greater, so Y must be less. Y is less than all of that, so obviously we shade underneath the roof if it's less than. Okay, so now I look at it. This region, no arrows. This region, 1 arrow. This region, 1 arrow. This region over here, 2 arrows. So that's the shaded region. Okay, you can kind of do it how you want. I just kind of go like this. If you had colored pencils and you could shade in lightly, that would be awesome. This markers kind of make it look ugly, but a colored pencil and you just shade that area, that would be fabulous. Okay, but I'll know what you're doing when you send me a picture. Okay, so there it is, a system of linear inequalities. Now, what does that mean? What that's telling you is you can choose any point out here in this whole region and it would satisfy both equations. Well, if we looked right here, the point 0, 0, that's the easiest one to check, right? And I don't have a lot of time here, so I'm just going to check that one. Let's plug it in real quick. If I plug 0 in here, that would be 0 is greater than negative 1 times 0 is 0 minus 2. Well, is 0 greater than negative 2? Of course it is. You'd rather owe me nothing than owe me $2, right? So the point 0, 0 is in the shaded region. It made this equation true. Now, what about over here? Okay. If we said 0 is less than or equal to 3 times 0 plus 6, right? Well, that means 0 is less than or equal to 6. Is that true? Of course it is. 0 is less than or equal to 6. Okay? The only way you'd ever get an equal is if it's exactly on the line. But that's cool too. So, sure enough, that point 0, 0 makes both equations true. Now, is there any way that you could ever list every point out there that would make both equations true? No. So if you can't list it, then you just shade it, saying, look, you could choose any point in this region and it would satisfy both equations. But if you chose any point from any of these 3 regions, then one or none would not be satisfied. One would be satisfied or none would be satisfied. All right, peeps. Now, this is where I'm just going to get real honest with you. I know at this point that all of this, doing math this way, is not the best, okay? And even as I'm just sitting here thinking about exactly what I need to do to help you, we're going to do 2 things. First of all, really, if I gave you 4 of these, right, that would be 8 graphs. So that's 8 problems, all right? So that's all I'm going to do is I'm going to give you 4. This is the first one. But because I'm giving you less, because I really think if you've done the other 2 examples and you've already done the other 2 assignments and you've already done the quiz, then you should be able to do this, okay? Because I'm giving you less, you have to do this honestly with me. In other words, what I mean is your goal here should be to learn, not just to get through this, okay? So I want you to copy this down. I want you to make your graph, and I want you to graph these. And I want you to do it because we're going to push pause on the video, and then when I come back, this thing's going to be solved. And why do I do that? I do that because you guys need immediate feedback. You need to know if you're doing it right or not. Okay, what's the good thing about that? The good thing is if you do it right, you'll be learning. It's the best way to learn. But if you do it wrong, you're not going to learn anything because you're just going to be copying what I wrote down and sending it to me. Which, I guess ultimately that's your choice. But I'm trying to make these assignments as short as possible because, trust me, I'm not real happy with the situation, but at the same time, we're doing our best. I'm doing my best. You need to do your best, and we need to get through this. So do the problem, push pause on the video, do the problem, then come back and check your work. If you did it wrong, then adjust, make the adjustments, learn from your mistakes, and then we'll do better on the next one, okay? So I'm going to do this assignment today. We're going to do 4 problems today, and then tomorrow I'm going to give you a quiz, and tomorrow I'm not going to give you the answers. I'm going to see where you're legitimately at, okay? But you're going to get graded on both assignments, but really only you know if you're doing what it takes to learn. So I'm hoping that you're attacking this thing in a learning mode, not just a jump through the hoops mode.